So, how's everybody doing tonight? Yeah. Awesome. Can I see a show of hands for who does not have a BLE smart device? Nope. You've got an iPhone, dude.
Oh, sorry, I thought you were talking about the mbed thing.
No, BLE smart device, like an iPhone or an Android phone that has BLE. Who does not have one? 1, 2, 3, 4. Okay, you guys should partner up with the person next to you who does have one, because this is very heavily dependent on having a BLE-enabled smart device. This is primarily because the mobile market has figured out BLE, and the desktop market is still like, what's BLE? And nothing really works yet. If you have a Mac, though, there is a program called Light Blue Beam. So if you've got BLE on a Mac, you might be saved. Go download that. It's both an iOS app and a Mac Store app.
Light Blue Beam?
Yeah. Well, Light Blue is the name of the thing.
Oh, then okay.
Yeah, so you should get that for both iOS and Mac if you get a Mac. Let me see what else. Make sure that both your smart device, i.e. tablet/phone, and your laptop are on the Wi-Fi. I guess I should ask, who wasn't here last month? Did y'all check out the stuff before coming about, check out the things from last month that was in big bold text at the bottom of the Meetup page? No, you didn't? Okay, we're going to drag you along kicking and screaming. The only reason I mention this is because we're going to use an online compiler for a lot of this. And it's kind of how we do things, which is why it was the first Meetup. So if you would go to mbed.org and sign up for an account really quick.
Mbed.org?
Yeah. It'd be mbed.org, and you'll need to sign up for a developer account. It'll take all of 3 minutes. Oh, and then pair up next to someone who was here last month who knows how to use it. Yeah, so you and him should switch places so he can help him and you can help him.
All right. Problem is I need power.
That's a long power cord. Just give me like a heads up sign when you get your account so we can move on.
Wait, which one? Oh, you know, I'm actually on an old, like one of the official GATT Wi-Fi, yeah.
In that case, just put them on the same network. I don't know which network. If you remember the password, just put them on the same.
Okay. Yeah, I do. What's the official cap? The official cap. No,
You good?
okay.
You guys, if you need the guest password, it's right here. Like, they're both right here, the big block print. So, this is basically outline for what we're going to do today. I've got about 10 minutes worth of stuff I can go over before everyone has an mbed BLE board. I'm still waiting on my co-patriot to show up with them, so I'm going to hope that in 10 minutes he shows up and we're rolling. Okay. So what we're going to cover today is what BLE is, what it's good for, what it isn't good for, because there's a lot it can't do and there's a lot it can do really well. And we're going to cover both an in-depth and a high-level view. We got room up front. I promise I don't smell.
No.
And so we're gonna approach BLE from an applications perspective, because I'm an applications engineer and that comes naturally to me. I'm not someone who lives in their mom's basement, so I do not have super deep technical skills that can only talk to computers. I talk to people all day, so I'm going to talk to you like you're people. Hey, you're here. Yeah. Cool. Okay. Yeah, just drop it. There's apparently a car on fire on Mopac, which is why I took self first.
Should have texted me.
Sorry. Anyways, so we're going to approach BLE from an applications perspective, which means we're going to go for what works, what doesn't work, and there's a whole bunch of stuff I'm just going to ignore because it's not relevant. You're trying to build something, there's a lot of BLE that you can just pick, and the stack will take care of it. And so we're going to ignore those parts, make it deep enough that if you want to hack with it, you can. Oh, and we've got 3 examples today that I'm really, really proud of. So what is BLE? BLE is a wireless, low-power, short-range solution. This is opposed to things like Wi-Fi, which are mid-range, and WiMAX and LoRa, which are long-range. So BLE will get from here to the end of the room and maybe out into the hallway to the front desk lady, and that's it. Beyond that, BLE stops, full stop. When I say ultra-low power, I mean it can run off a coin cell battery if you know what you're doing for 1 year to 3 years. That's groundbreaking. Because if you've ever done a wireless radio before, not only do they get hot, but they chew through batteries like that in under an hour.
Is that transmitted or is that with a 90% sleep?
So BLE is 90% sleep by definition. The way it works is it blips on for a very short amount of time, sends a very small amount of data, and then goes back. And to a large degree, you can adjust that from about 7 milliseconds to about 4 seconds. But that's still only 7 milliseconds. And of that 7 milliseconds, a microsecond or 2 is actually data. So even if you adjust it all the way down and make it send as often as it can, it's still 90% sleep. And that's been engineered into the specification at the lowest levels of the stack, which is why BLE is incompatible with Bluetooth 4.0, which is kind of a misnomer because Bluetooth 4.0 includes BLE, but is Bluetooth traditional. And one's called Smart, and then together they're called Smart Ready. And there's like 7 different acronyms for this thing. And so I just say Bluetooth 4.0 traditional and BLE. That's how I separate them, and I'm going to keep them separate like that. BLE is slow. Because of that small data size and infrequent sending of data, it only gets about 30 kilobytes a second. The technical physical bandwidth is 1 megabit a second. The practical application, after you have overhead that takes away like half of your frame size, and you have to wait on people with collisions and such, means you got about 1/3 of a megabit. When you divide that by 8, you get to right around 30 kilobytes a second. So that's the number that I chose to put up there. For those of you who have tried, this will not do audio streaming, this will not do video streaming. This will do temperature measurement 10 times a second very well. You will not send a photo across it. Or if you do, it'll take a couple minutes. So that's what BLE is. So if you had any ideas of coming in here and doing audio streaming for super low power, it doesn't work like that. Also, BLE's got this really nice paradigm where you can send 1 to many or 1 to 1. So if you want to do something like mesh networking, you can. It's part of the spec now. I don't support it yet here, but it's part of the spec. It's coming. So this is the stack. This is what BLE looks like. See all these boxes? It's a lot of boxes. We only care about those top ones. All that stuff below that, you should never have to touch unless you're inventing a new protocol, in which case Microsoft is paying you way more than I make. So we're all here to build things, right? We only care about those 2 levels. The GATT level and the GAP level in particular are the building blocks for everything else that comes above it. GATT is used for data transmission. GAP is used for connection management. GAP is also used for advertising. Also things like security and key pairing, but we're not going to get into that. Just GAP is for advertising, GATT is for data. Say it with me. GATT is for
GATT is for data.
Thank you.
Are you going to share the slides at some point? Or?
They're already on the Meetup page.
Oh, very good.
Yeah. And in fact, about halfway through this class, you're going to be able to pull them live from this little beacon right here.
Okay.
What do you mean by advertising?
I'll get to that. So, I'm glad you asked that question. There are 2 fundamental modes that BLE operates in. There's an advertising mode and a connected mode. We've got seats up front if you want them. So an advertiser is broadcasting stuff out into the ether. It works just like any other radio signal does. Technically, radio doesn't go in a straight line. It goes in like this bubble shape. Advertising uses that and goes, hey, I'm sending things out in a bubble. Anyone in my area, pick up on this and do with it what you will. The advertiser is sending the data. The scanner is sitting there listening, not doing anything, just picking up on the data, eavesdropping essentially. This is all done again via the GATT layer with a P. The scanner can then initiate a connection if it wants to. It does that over GATT, and then they go into a new mode. This is where they're connected, and they transfer data back and forth via GATT. The advertiser becomes the server of data, the scanner becomes the client. So again, we've got these two fundamental modes, broadcasting and connected, one with an advertiser and a scanner, one with a server and a client. Anyone confused? Cool. And I should mention, if you go and read in the technical papers, the server-client thing switches back and forth depending on who's sending data, because it's from the perspective of the data in which direction it's traveling. So if I send you data, I'm the server and you're the client, but as soon as you send something back to me, you're the server and I'm the client. So during a GATT transaction, stuff will flip multiple times, but I'm just going to broadly simplify it and say, from here to there.
So is it typical of the process that first you're in GATT, you find someone, and then you're in GATT because you're sending data?
So like if you've ever looked for something on your phone, it's broadcasting out in GATT, and you are scanning in GATT. And then you click on it, and you send a little thing back that goes, hey, I want to talk to you exclusively. And he's like, okay, I'll be exclusive with you. And then you're over a GATT connection one-to-one instead of one-to-many. There are ways of automatically doing that, but it all still goes GATT to GATT.
But is it exclusive, or are you saying you can have multiple connections, right?
So in advertising mode, it is one-to-many,
Right.
and that is because there is no sense of a session. It's just like UDP. I'm sending it out, and whoever catches it will catch it. And as soon as we transition over to a connected mode, it is strictly one-to-one.
So once you do the handshake, you cannot do a lot of one-to-ones with other, right?
Actually, you can.
Right.
If you're a central role, you can connect to you, and I connect to you, and I connect to you. But in our session between us, it's straight up you to me, you to me, you to me. But I can have
send your
multiple.
data when you're in GATT too. You can beacon out like your temperature probe.
You said in GATT?
In GATT, in the broadcast.
I'm going to get to that. Jumping ahead of me here. Yeah. You can transfer data in both modes. You are correct. It's just how much and how secure you want it to be. GAP is never secure, ever. And you have very little data. GATT, you can do a lot more, and I'll get to that in just a second. So one quick note. You don't really have to know this, but I decided to put it in, so if anyone ever asks you, you can say you know this. There's a thing called frequency hopping spread spectrum. It's how BLE does it at the basic level. And essentially, you've got 3 channels, these green ones, of advertising. The blue channels are all data. All of them are a little bit apart. And the way BLE works is when you and I decide to have a conversation, we go, I don't want this guy next to me coming in and walking all over, so let's walk and talk, okay? And what we set up is a key to jump by so many channels every so often. Usually you'll see it between 3 and 10. So like if you and I wanted to talk into BLE devices and say, let's walk and talk and let's play hopscotch by 6 at a time. And so we'd start out, and after set interval time, we'd jump by 6 frequency bands. We talk in the set amount of time, then we jump by 6 frequency bands. And this keeps happening over and over and over again. It's a moving target. This allows BLE to exist in the 2.4 gigahertz spectrum, which has Wi-Fi and microwaves and everything else that's incredibly crowded spectrum. By using this technique, you can have a couple hundred devices in a room and be just fine. That said, you'll never have to know that. So this is the BLE packet layout. Regardless of what you're doing, whether it's GAP or GATT, every transaction that's sent across the air has got 47 bytes. Every time I wake up and send data, there's 47 bytes of data. Well, 47 less 39, depending on how full it is. But if you send everything at once, you get a maximum of 47 bytes of data. Of that 47 bytes, you can't use all of it. About half of it gets eaten up by the stack by the time you get to your user data. So if you look at it, you've got don't care, and don't care at the end, and this PDU right here in the middle of 39 bytes. That stands for packet data unit, and it's where the data goes. There's many types of packet data units that correspond to everything that BLE can do. We care about 2 of them, which is the advertising payload, which is what you're talking about in GATT. And there's the attribute protocol, which GATT uses to send larger chunks of data in a secure connection. If you'd like to, you can Google the other terms in black, and you'll find all sorts of really cool technical documents that make my head spin. When you choose to do GATT, we're going to do GATT first, and we'll get to GATT second. For GATT, that 39 bytes gets split up like this. There's a header, and there's an address field, and you don't care about them because you don't access them. The stack takes care of it. There's 31 bytes that you get to play with. That 31 bytes makes up everything from URI beacons to alt beacons to a large number of custom protocols that exist for a lot of startups in here. This 31 bytes has got a series of structures inside of it. The structures can be of varying lengths, anywhere between 3 bytes and 31 minus 2 bytes. That's because every structure has got an overhead of 2 bytes on it. This is because BLE comes through as a stream, and so it processes it like a stream. So the first thing that comes through is the length, and it goes, okay, this struct has got so much length. Let's say the length is 2. Okay, I've got my length field, and I've got 2 more bytes to read till the end of the structure, and I'll start this whole process all over again and look for a new length byte. So it looks for length, looks for a type of 1 byte, and then the data is 1 byte is the length minus 1 byte. Questions? Nope. All right.
On the length minus 1.
Because the length gives the length starts from the end of the length byte and encompasses the rest of it. Since the type byte is 1 byte, that means this length right here, the data length is this whole thing minus the length of the type byte, which is 1.
That's within the PDU, right?
Right, so the PDU is this whole thing.
Right, and there's that.
And then this gets dropped down into a series of smaller structures, each of which looks like this. So I've got an example for you here. So let's say, wow, that has got way more space at the bottom of my screen. So let's say we've got an example that looks like zero two 01 06 and then 04 FF 112233. What I'm going to do is say this is my first byte. So my first byte is the length, which is of 1 byte. So this is my length. Then I'm going to say my next byte is my type. So this is my type. And now what I'm going to say is how much length do I have? It's 2. So 2 bytes. That's my data right here. Data minus 1. So this becomes my data. Does everyone see how I did that?
Yep.
Cool. Okay, so what does this for me?
Well,
Right, is my length. New pack. What's this FF?
type.
Correct. It's my type. Pop quiz. Who can tell me what a type of 01 is? Great. What's a type of FF? There we go. Y'all are catching on. All right. So what is this data right here?
3 letters of the
Manufacturer's data.
That's manufacturer's data.
You got it. That's how you read every advertising packet that comes in. I can have up to 31 bytes filled with any number of small structures. The point of doing this exercise is to show you that 31 bytes is not free. Each field you put in there has got 2 bytes of overhead. That's important to notice because here in a bit, if you try and shove 31 bytes of data into that field, it's going to blow up and be like, I don't know what you just did. I don't have 31 bytes. I've got 29 bytes.
So you have to maximize so that you use the 31 though, right?
Right.
To be efficient.
Right. And so what you'll see a lot of people do, I actually included this on purpose. This 020106 is on the beginning of almost every advertising packet you will send out, because every advertising packet has to say what type of advertising it's doing. Whether it's broadcasting, connected, unconnectable, just general discoverable, they all have flags. And so every advertising packet you put out there, by default, loses 3 bytes to flags. So that 31 bytes is really more like 28. You don't get to control this directly. Whenever you set your flags, they're automatically computed and put into this little byte right here. So effectively, you have 28 bytes left to put data in, which really you lose 2 of, so you get 26 bytes. So when you do advertising, you have 26 bytes of data to shove into any field you like. The most popular one is what I showed right here, manufacturer data. This is how iBeacons work, in case you're curious. They take the manufacturer data field and just shove stuff into it and partition it up.
Do you have in the data on that part, do you ever have multiple types in one?
No, so the data is data. It's just data.
But it has to be associated with the type you're saying.
Right.
So do you normally have lens type data in a single 31 byte? You do, right? You can.
Yes, you can have multiple in there, or you can have one length type and then data of 28. You can totally do that. The problem is, again, remember, you have to have the flags there. So really, it's length type data for your flags, and then length type data of 26. And that's exactly how iBeacons, URI beacons, and alt beacons work. In fact, all beacons work like that. Nope.
So they're sending, people who are using it to transfer information, including the agents, they're using the manufacturer's type in that first part of the header, and then they put their own encoding in the rest of it.
Right. And what happens is they'll usually put like a hash in the beginning. In the case of iBeacons, they put a hash that is their SIG company ID of 4C00. So whenever an iPhone scans an advertising packet and it goes manufacturer data, 4C00, oh, that's an iBeacon. Okay, parse the rest of this with some set protocol. That's how they all work.
There's a lot of enveloping, kind of. Right?
Yes, every wireless, if you've ever done RF engineering, there's so much enveloping. It's ridiculous. So that's how we've gone now from 49 bytes
It's just
down to 26, because you lose 2 for overhead.
That's like the layering that you use for a transport protocol.
Yep. Yes, it is. Okay, so let's do example number 1, using advertising packets. Who does not have a BLE embed-enabled board? Raise your hands. Brian, Sam, if you would, please distribute widely.
I didn't bring a laptop. So I'll just
Yeah.
speak here. That's okay.
And then there's a gentleman, you need a table. Come over and get a table. Then we will use these first. Also, I'd like to take this opportunity as we're distributing boards to everyone to thank Don in the back from Aero Electronics. He has made everything fully possible by helping us out and donating boards for us to
Probably, yeah. Oh, there's one more guy. No, it's not. In this case, light blue is both a software and a hardware thing. I just like the software because it kind of take a guess of what it is to use it for Apple's. Yeah, I come back today and last call, everybody has a cable and a board to manage something. Good. All right, for those of you who remember how, go add the platform that you just got to your mbed platforms. Remember how to do that. Do it. Hey, Austin, what do we need to do? Sorry, I wasn't in Austin. Okay, so the board shows will use as a USB drive. Yeah, so I've already plugged it straight in. Can you? Okay, so open up the board when it installs. There's an mbed.html. Okay. Double click on that, it'll add it to your computer. So I logged in. Oh, it's online compiler. So there's nothing. That's awesome, isn't it? Right. What company was it? At the board your compiler. We couldn't find the driver.
So what do you guys do on part one for your second
Make sure you have both your smart device and your laptop on.
You have an Android, right? Yeah, so maybe you have
You send an email that we need to download the latest driver for this board.
Yeah, you
Go do it.
should have to install that.
No, the players.
Okay, if you would look at your USB drives.
So then it should pop up.
This jailing.
Well, it's just basically, there's a lot of this board creation system as a
What is
USB.
it? Right.
So there's all, that's like the. So that's your code. So we just sit there, so you don't do anything there, that's basically. Then you go to the
Yeah, well, that's what you're gonna use then.
It's up to you. There's nothing else on there except the driver and the truck.
Yeah, so it's kind of installed right now without it. So because it's driving on.
Windows. Stuff repackaged. You got to download it. Okay. You'll find the device you're going to load it.
So which do I need to do with order again? You said download from the studio site.
Well, just save it on.
Serial drives.
It's on the side of the driver and the thumb drive. You have the device plugged in, so all you got to do is fire up that piece of code.
About my computer.
Making sure the board is plugged in and added to your online compiler.
So I added.
Downloaded programs.
Did you add it to your online compiler? Are you at the right target on the So, guys, can I get your attention? Up here. I'll do a song and dance if I have to. Who has not added it to their online compiler?
I don't know what that hell you mean.
Who doesn't know what I'm talking about?
I haven't done it yet.
So all of you, all the rest of you guys have got it. You can compile for it. You're good to go. You've.
I have not.
Okay.
Yeah, I know what you're talking about.
All right, I'm going to show you how to do it. So, what I'd like you to do is go to developer.mbed.org. This should be the website. If you click on platforms, and then scroll down the page to the board you're using. For most of you, that's going to be the NRF 51822DK, if I recall. Where did it get off to? That's not it. Right, so this is it. So you find what you're using. In your case, it'd be a CDarch BLE. In your case, it's a Red Bear, and everyone else, it's this board. You click on it. And there should be a button right here that says Add to Compiler. Mine says Open because I've already done it. So make sure you've added it to your compiler. Otherwise, you can't target this board, and whatever you try and build for it will build for something else. And that's like trying to put gas in a diesel. It just won't work. So make sure you're putting the right thing in the right place. All right, cool. Back to the slides. So we're going to do a Google Physical Web UUID. That's a lot of buzzwords. What it essentially means is URI beacons are kind of like glorified QR codes. They're in their infancy. They're kind of a side project being run by Google at the moment. They take shortened URL links, like bit.ly or goo.gls, which are like 8 or 9 characters max, and they put them on a beacon type device, and they broadcast them out for anyone to have an app up and click on it and jump through the stuff. You're going to see a bunch of them at South by this year. There's going to be a whole lot of cool stuff going on around it. In the future, they're only going to get more awesome.
So that saves the scanning part of things?
Right. It allows you to interact with something with your phone running something in the background instead of having to like pull out your phone and focus it and get it just right. Or with NFC, which is even worse, waiting for it to synchronize and everything
How
else.
do you decide, because obviously with the QR code, you're making an action, making sure it's within range. And here it's just...
Here it would be a, hey, we found a thing.
Right.
And just like any other notification, you can be like, dismiss it or check it out.
That could be busy in like South by Southwest setting.
It could be, which is why you can then filter it and do other types of things for it.
We can send all your Bitcoin to us.
It says you can't install it.
Don't put your wallet on your phone, don't your device.
Please show me your computer.
Great for hacker.
Click on computer.
Go to this website, the whole hacker.
Yeah, for free.
For free.
Well,
Beacon hacker.
He's having driver issues.
Yeah, I think I've got that.
Okay, anywho, so URI beacons. Please install a physical web application. I assume most of y'all did this as we were sitting here waiting for boards to show up. Search for physical web on the App Store and install it. You should find one beacon nearby. So go ahead and run the app. You should see one thing pop up. That's the thing that I'm running right here, and it has a link to the slides for the presentation.
So that's basically
Broadcasting.
So it's in GATT.
GATT. And it has 26 bytes effectively to get things across to you. I'll show you the packet and how it breaks down at the end.
And that's again, sort of, the data protocol is what Google defined, right?
They put it
to speak that language.
right. They shoved it inside of manufacturer data, and then everything inside of that they partitioned it up.
So it's the type that identifies that manufacturing data. But then within the manufacturing data, how do you establish whether you can talk that?
You have to know what it is. There's no key handed you with the data. It's just you have to know what you're looking at. That's why they publish a standard.
I have 6 stages.
Okay.
Physical web app?
Yeah.
Ooh, someone else is developing.
Canon or something.
Okay, I definitely haven't tried to install it.
It should be. Trying to install what? Click on. So junk is what it's called.
Well, he gave us the driver on that little.
Oh yeah, don't worry about the driver. You don't actually need it. It's only for the serial part of it. We're not getting the serial.
So here it's saying there's 2 things. When I plugged in the board, there's 2 things that came up as failed. CDC.
No, you're fine. You're fine.
Okay.
Because you can see it right here as junk, so you'll be able to drag and drop it.
So that junk is that's
Yes. If you unplug it, you'll see
We
this.
saw the ROM tab is E. That's the driver. So go ahead and try to install the driver.
Pull that up and make sure it stays.
Double click on
So now I'm going to have y'all. There's an app called Physical Web.
That's an important part. This is the trouble chart.
For everybody else, we're going to go ahead and compile that code now, and you're going to run it on your boards. So if you would, please follow this link. You can either type in this short link if you like, or you can go to mbed.org/BLE, look in the code section, and then look for URI beacon.
In this case, the real URL is easier.
That's not even the real URL, that's a shortened one. It was like
BLE,
this long. Oh, the BLE one?
Right, I'm just saying.
Yeah.
In this case,
Yeah.
it's almost counterintuitive.
So go ahead and go there. Since everyone's added their platform to the compiler, you should be able to just import the code, compile it, and then save the binary to your board.
So for those of us that don't remember how to do that.
So go to the page. No, it's on the page. You want to go to the UUID. So go to mbed.org/BLE. Find the BLE URI beacon code. It's in the code section.
So under BLE, we should have a BLE underscore URI beacon.
Yes. So if you,
out beacon.
you go to mbed.org/BLE. If I can get this work. I then click on code. Code right here.
You were there. Yeah. URI beacon, that one.
And I scroll down to URI beacon, which is right here. Click on that. And then right here on the right is import program.
Got it.
Either one will work. It's a short link from both domains.
Import the folks.
Yep, just import it. Go ahead and bring it in. In your compiler, you'll click an extra 2 buttons to just be like, okay, that's it. This is what the BLE URI beacon code will look like.
Yeah, there you go.
Mine looks a little bit different. So your code should look like that.
Yeah.
What you want to do is you want to change this string that says mbed.org to something else. Anything else. It has to be small though. Remember that 26 bytes? You've got 26 bytes to use. Because of the overhead of URI beacon, you actually have like 10 bytes. So keep it to 10 bytes or less. You can do this by doing URL shorteners. So like go check out tin.ly or goo.gl or bit.ly. Take whatever you want, use that URL shortener, it'll give you a short link, and then put that short link in here. So like if you look at mine, I went to goo.gl, I took the really long thing that I had for the slides, and it gave me this short link. So get a short link and put it in there.
Yeah, there you go.
Long URL. So it just does a hash? Is that what it is? Or the...
Oh, it's a cert. They do whatever they want to on the back end. It's magic as far as I'm concerned. Once you have that, go ahead and compile it and download it to your board. You remember how to do this. I can see the board in front of you. Should have brought your laptop.
So, 6 and then...
Oh, yeah. Those are 2 folders. You just drag and drop it.
Oh, it's showtime.
So I'm going to cheat and I'm going to put my name in here because my name is a website. So austin.com, make sure you put something else in. Put your name in. Put your initials in. I don't care what you do. Just put something in.
So that's what it's going to be.
Broadcast out. So now I'm going to hit compile. Oh, by the way, look in the top right. You want to make sure it says NRF 51822DK.
NRF 51 DK.
Yeah. So you want to make sure that your target is what you're compiling for.
Did you say 5.1 or 5.122?
It should say Nordic NRF 51-DK.
Gotcha.
In your case, it would be Seed Arch BLE, and in your case, it would be Red Bear Labs. Because they have different boards.
So when you did your, what was it?
Who's talking? Okay. Anyhow, so once you've changed it, hit compile. It's right here at the top, right next to save.
So this is compiling
On the server and handing it back to you. Save the binary to your computer, and then drag and drop it to the USB drive. Just like you would a PowerPoint or a Word file. It's just a USB drive and it's just a file. I'll switch my back. Illustration. Yes, ma'am.
Is everything on the board blinking when you're dragging the?
Yes, it'll. As you program it. This should.
What is that? It's just the full level for
So it might be called jump. So the boards that we're using today may have a different name. They may be called mbed or they may be called JUNK. Right. Oh, that's an L. Sorry. Sorry, the L I read as a U. Right, and it was really close.
You just copy it to J-Link and then...
Yeah, drag and drop it, and you'll see the little light go off, and it'll program itself.
Kind of wasn't watching your
So just like this, you'll take the file,
And he goes through an install.
and you'll see it go.
We didn't drag, we copy and paste. What's the difference? Is just the triggers a different thing?
Operating system specific shenanigans. Everything is different. So find the file, just drag and drop it. Okay. Once you've programmed the board, once you've dragged and dropped your file across, hit the reset button on the board, and it should be broadcasted.
Just trying to open it.
So now if you look on your physical web app, you should be able to see your beacon.
How many bytes do we actually get, J-Link?
Assume 10 or less.
Assume 10 or less.
So like you can do your initials. The link doesn't have to be valid. The link can be anything, just as long as you can look at it and see, oh, that's a unique thing. Awesome. So right now, if you look at your physical web app, you should see a beacon called Austin.
So I must have restarted the box. I was trying to reinstall the drivers.
So,
Wow, there's a lot of people who've said So who's got disk.io?
Yeah, are you going to right into the device?
For me, I've got.
So I have the house file. Did you just do it? Yeah, right.
Which tool are you using? Which app to find the stuff?
Physical web.
Physical.
is that the name of the
Project. Yeah, it's called the Physical Web Project.
And that's just creating some QR codes out of the
Pretty much. Check it out. I see Austin.com. Right there, because that's what I do. This is what everyone else is doing.
It actually shows the
What it does is it pulls the short link, and then it shows the metadata. Yes,
that's just the app.
So I've got a Windows phone, and Norton's got in our toolbox. Think that'll do it for me?
I will use the toolbox first. You need to be physical web as well.
Okay, so my question, then how would my neighbor's phone know my beacon? Because we haven't identified it. This program is me. Oh, okay.
Because I'm purposely avoiding very critical parts because it's really confusing.
So no one's able to see their beacon.
Oh, I can see mine right here. There's mine, Austin.com. Using the physical web app.
Oh, I see. Okay, so the URL that we keyed in there is now showing.
Yes.
Ah, I get it.
That's what we're doing right here. So like right here, I put in Austin.com,
Right.
and there it is.
Okay, so that's what, okay, I get it.
So, who can see their beacon? You can see your beacon. You can see your beacon. Of course you can see your beacon. Hey, good job. Can you guys see your beacon? Can you see your beacon? Yeah, you gotta press the reset button.
Does Google have it?
You don't have to on the iOS.
Yeah, they have a special sauce piece of it. We're trying to do that. Everyone has sometimes
It's called Light Blue, the app?
but that's not the one we're using. I know we're using physical.
Is it
It's a non-issue, right? So, who's that you're saying?
Yes, sir.
Just the URL, it's downloaded all the code. No, it's just
What's the range of
Maybe after the door. From wherever you are, replace this with hit your desktop from there, and then also replace that last one. And just always keep this up. Don't do the access file, just do sub.txt. So it only looks for one file, and when you're done, just delete it off. Put it to trash after you do the copy, so you can always just up arrow insert it. Don't forget the last bootloader to do.
So what do you need to, if you want to develop app like this guy?
So you just need the BLE support. iOS and Android, anybody with that hardware. So those are probably the easiest right, so you get that payload in the advertising package, you start parsing it. Exactly. You start doing your lookup, you start capturing bits of the pages like they do. So you can actually
If I do the filing one more time, it's the board that's doing it.
But the next time you download, it could have a different
No, I won't install.
Still not liking it?
Just the J-Link getting installed.
This is gonna sound like another stupid question, but I'm assuming you try to make it that might be, I mean, that might be one more thing, I don't know.
Is this the smallest thing known to get to the BLE thing, or it can be smaller?
It can be smaller.
I feel like that volume.
I'm actually not the expert, but we do have some small packages.
I'm just curious from a hardware point of view.
There's an SoC.
This is obviously a general purpose board, right? BLE just happens to be one of them.
False. This is a BLE socket that happens to have an M0.
Okay, but then is it that big?
Oh! So this is just, so if you change that to the BLE, That middle thing, it's got BLE and the Cortex and 0
So what is all of that?
All this extra stuff is just breaking out all the pins to get this thing. Oh yeah, no, it's a development.
More development.
So these are the yes.
So you can put this anywhere, and this will work, but it has to be power. How does this work? So this is the chip, and then you have to have a board.
Right, I mean the board. This board does the same thing.
But without the development.
Without all the things. It has the same chip. You can run the same program. You can. That's called the Nordic. And then just copy and paste. You can find those for $30.
Is there some already finished included?
Yes, you know. We should talk. So who does not have their beacon working? I can see show hands. Does not have it working. Okay, cool. I'm going to move on. So, for those of you who are asking, this is the payload that goes inside of that advertising packet for URI beacons. This is why you only had 10 bytes of data, essentially. Because that 31 bytes, which is the 80 flags, gets dropped down to 28 bytes, which is here. You'll notice right here, you've got your 80 length, your 80 type, and then you've got the rest of this data. All of this cruft right here is what tells the program that's reading the beacon manufacturer data, this is an iBeacon. So this 1, 2, 3, 4, no, that's 1. 1, 2, 3, 4, 5, 6, 7. Those 7 bytes. That's what says I'm a URI beacon versus I'm an iBeacon versus I'm something else.
So,
in fact, if you look at it, yeah, service UUID. That would tick it off, and then the rest of it just follows through the packet.
So if there's no standards there, how does your, I mean, if you're trying to support multiple things, you gotta just kind of iterate through it until it matches?
Yeah. So like for an iBeacon, this would be 4C00, but then what you can check is this would be 00 on a iBeacon, right? But clearly the length of the rest of this is not 00. So then it'd be like, oh, that's not an iBeacon. So you just have to have parsers that check. Thankfully, on Android and iOS and Windows Phone, they actually have libraries. And you don't have to manually manage this part of the data field. I'm making you aware of this because next month we're going to implement custom services, and you will have to directly manipulate this, and you'll have to create your own spec. So I have to tell you about this so that next month we can do it. If you don't want to mess with bit twiddling at this level, don't. Just find a thing and be like, hey, iOS, what is this thing? And it will turn back and go, oh, this is an iBeacon, or this is a URI beacon, or it'll decode it for you.
Or is I don't know.
Or is I don't know. And then you'll be like, okay, it's a URI beacon. Give me URIbeacon.data. And it will hand you this data right there. So there are high-level APIs if you don't want to twiddle at this level. But now you understand why there's only 17 bytes you can cram onto that shortened URL.
It said 10 earlier.
I said 10 to be safe. I tried 20 earlier and it crashed, so I was like, cut it in half and it'll probably work. Again, applications engineering. So now I'm going to, too far. Now I'm going to go on to talk about GATT. We just did GATT, and that was all advertising. So what we just did was, one, broadcasting out, anyone can read it. Now I'm going to talk about what happens when you get a connection, and we talk mano a mano. GATT has got 2 or 3 things. It's really a hierarchy. You've got services. Services have characteristics. Characteristics have a value, and descriptors. There can be multiple services coming from a device. Each service can have multiple characteristics. Each characteristic can only have one value. That value, though, can be multiple bytes. See what I mean? Each characteristic can also have multiple descriptors. In practice, descriptors are not used because, much like you just saw, when you send data, you're like, hey, it's this thing. And the thing goes, oh, okay, I know how to read that. Don't worry about it. Descriptors were intended by the BLE Foundation to describe the data in the characteristic. So the original intent was you could walk around and scan for any BLE device, and it'd be like, hey, I'm roughly this thing. And so you try and figure it out. BLE, it turns out, did not evolve that way. And so no one uses descriptors, but they are there if you want to try and describe your characteristic data. If no one else will use them, you will be a special person. So yeah, that's how things break down. Notice there's a GATT server, multiple services, service has multiple characteristics, characteristics have multiple descriptors. Any questions?
Could you give like a real world example?
Yes, on the next slide. Actually, yes, I very much like to. Oh, one thing I forgot to mention, characteristics have got 3 metadata properties, read, write, and notify. This is how you can do basic things like control that lamp back there on that desk. I would find its service, and then I'd say, is it writable? And I would read the metadata and be like, yeah, it's writable. And I'd be like, cool, write 15 at it. And as soon as I write 15 at it, it's going to start glowing. Because inside its internal program, it has a thing that says, when someone writes 15 to me, I do this. Cool? Okay. One more thing. There are things known as profiles. These are used to help you conceptualize and understand what is what. This is because you can actually have services and characteristics that are named the same thing. It's really infuriating because the SIG was like, oh, a heart rate characteristic and a heart rate service are different. Except if you're not paying attention, they both sound like heart rate, right? But they're very different things. So there's this concept of profiles. Profiles aggregate multiple services together. Can you not hear me? Over those guys? Thank you. Can you hear me now?
Wait a minute, I can start.
So profiles are a way to conceptualize data. So if I had a heart rate profile, the heart rate profile is defined to have the heart rate service and the device information service. 2 services together make a profile. It could be 3 services, it could be 4 services. These things are all well defined, and I'll show them to you in 2 slides, what is what. But that's how it goes. Profiles aggregate services, services aggregate characteristics. Every characteristic has 1 value.
Which is multiple.
Which can have multiple descriptors, but usually doesn't. So it's profile, a bunch of services, each service has a bunch of characteristics, each characteristic has a value.
So what's the properties there? I thought it has properties in it.
That's coming for heart rate monitor, which I'm going to get to in a second. So for example, actually you're right, I should go over this. So for example, the heart rate profile. 2 services, heart rate service, device info service. The heart rate service has got 2 values. One says, hi, this is my beats per second, my heart rate beats per second. And the other one says, this sensor is located somewhere on my body. So if I write the heart rate service, I get 2 characteristics. One with, say, 100 BPS, because I'm kind of sweating right now. And the other one would say, oh, it's located on his ear. So 2 characteristics with 2 pieces of data, part of the same heart rate monitor service. The device information service would then give me information about the device. In this case, it actually has like 8 characteristics, but it just goes on, so I truncated it at 3. It would give me like company name, firmware revision number, software revision number, hardware revision number. There's a whole bunch of things you can fill in. And so for like manufacturer name, I'd then have a string as the characteristic value. And so you'd read device info service dot manufacturer name characteristic dot value would equal Austin Incorporated.
This is why it's going to be important to have standards. Otherwise,
right. And that's what I'm about to tell you about. Each one of these, the S1s, each of these services and each of the characteristics actually have a unique number given to them. Heart rate service has got a number. Heart rate characteristic has got a number, and they're different. And that's how you tell them apart. Because it doesn't send over the air the raw English description, because that doesn't matter. It sends a hash. It goes, this hash means it's this thing. Those hashes are called UUIDs. They're used in everything in modern computing, from Windows driver development to making the internet run as a whole. Those tiny URLs we used earlier was something.com/a-hash. In this case, UUIDs have 2 forms, 16 byte or 2 byte. 16 byte, anyone can generate themselves, and you just use it. The problem is it's 16 bytes. So of those 26 bytes you have, kiss 16 of them goodbye. It just instantly goes out the window. It's a huge overhead. So the Bluetooth SIG was like, you know, if you pay us some money, you can have a short one. And we'll just say it's okay and make it part of the standard. So if you join the SIG, pay a lot of money, you can get a 2-byte one. And that'll save you a lot of overhead and therefore a lot of battery and therefore make your device more, worth
But
it.
that's if you have something unique. If you're building a hardware deal, you just use that code.
Right, if you're a hobbyist at home, use the 16-byte one, accept a small hit on performance and you're good to go. Or if you want, you can take one of the 2-byte ones and just fake it until you make it.
So 16 bits means 64,000, and then you're done. I mean, so Bluetooth Special Interest Group, I mean, they've got 64,000 to hand out, and then that's it. They're done.
No, then they'll just appropriate a new one. They'll come up with something, I promise you.
Bytes.
No, he's talking about the
IDs
2-byte.
can they generate? Yeah.
So, correct. That means they have 64,000 possible services and characteristics and several other descriptors. Currently, they've got well under 200. If BLE is not irrelevant by the time they hit 5,000, I will be very, very surprised. So I don't think running out of space in that 2 bytes is ever going to be an issue for them.
Taken off.
Right, it's a service and characteristic. This isn't by device.
Okay.
This is by thing I'm broadcasting, data type.
A heart rate monitor or a temperature gauge.
Exactly.
So the 128 is.
So what?
Is this in every packet?
This applies to the services and the characteristics, and then other data types as well, but mainly service type and characteristic type. So like,
so that
let me show you,
S1 that
actually.
you showed is going to have a 16-bit number associated with it.
Say again?
That S1 and S2 that you showed is
Yes.
going to have a 16-bit.
Yes. Instead of S1, it would have hex 180D
Right.
for heart rate service. Instead of C1, it would have hex 2A0C, I think. And that would come across, and then your interpreter would go, oh, hey, that's the heart rate characteristic or the heart rate service. It's on machine stock in numbers, not in English. That's why I didn't mention UUIDs till the end, because I didn't want to speak machine, I want to speak English. It's important to note everything has a UUID. Everything. The entirety of the BLE spec is a giant BLE lookup, as a UUID lookup game. In about 7 slides, I'm going to show you how to play that game, because it took me a month to figure out how to do it. So if I can teach you all in half an hour, I'm going to be very, very happy. Question?
Yeah, so does that imply that every BLE stack that's out there basically has all of those UUIDs in there?
No. It means the UUIDs are transmitted each time. You assign them to them. So what you broadcast across the air can be gibberish. It doesn't matter. You're just shoving it across the air. If you want anyone to understand you, you better encode them right.
Right.
So BLE stacks do not have the UUIDs built into them by default. The BLE stacks just shove data out. It's what you build on top of the GATT and GAP layer that allow you to interpret it. BLE is still in its infancy, by the way. There's a lot of stuff out there, a lot of debuggers that will just hand you this raw UUID. In fact, you're going to see it when we use the light blue beam or the light blue application or the NRF master toolbox. It's going to be like, here's a UUID. It's just a splat of numbers. And what you're going to do is look at the first 2 bytes and be like, 180D. That means heart rate monitor because I looked it up on the website. The application will not tell you that because when the application was built 6 months ago, they didn't figure out to do that. It's rapidly evolving. And so you have a lot of niceties that just don't exist.
So the BLE standard itself is only at what layer? Transport? What would you say?
The BLE stack defines everything top to bottom, but most stacks that you use will not define the UUIDs to English hashing. Ours does. The mbed one, it does, because I went in there and manually added them myself to make it easier. Anyways, to that point, let's get to example 2, heart rate monitor. So we're going to name your beacon. What we're going to do is go back to the website, and you're going to pick up, this time, instead of URI beacon, pick up heart rate monitor. Import it into your compiler. And what you're going to do is you're going to compile your program first to make sure it will compile. If it gives you a binary, don't put it on your board. Just don't do it. What you're going to do is then change the name of your beacon, compile it, and then put it on your board. This is because iOS caches things.
So it's BLE heart rate, not heart rate monitor.
Yeah, sorry. Heart rate. That is the name of the example, my bad.
You go back to
Sorry, there you go. So make sure you do not put it on your device yet. This is because Apple does weird things with name caching. Yes?
So the Bluetooth low energy is part of your general Bluetooth in terms of turn on, turn off on your devices?
Yes, when you turn it on and off, you turn off all of it.
Okay. There it goes.
Yeah. So get this program, put it in your compiler, compile it, do not download it. If you're not prompted to download it, you have an issue. Call one of the three of us and we'll come fix it. Or at least show you how to fix it. We'll teach you manufacturing. Okay. The reason I told you not to download it is because iOS has this weird, funky internal system because Apple developed a lot of BLE before there was a BLE spec in place. And so they've got some funky things in their internal system. One of which is when it finds a BLE named device, it caches that name to speed things up. It keeps a local copy of everything. So when you change it on your device, it doesn't refresh locally. It just holds that for like 20 days or something. It's ridiculous.
cache.
Yeah, and you can't clear it either. I've yet to find a way to clear it. So what we're going to do is you're going to go into the code now, find this line of code. It says Nordic HRM, it's the thing in quotes, it'll show up as pink. Change it to your name. Change it to something unique. Because when 40 of us put ours up, I don't want 40 Nordic HRMs. I want 40 differently named beacons.
HRM1? HRM1 is what it actually is. It's called HRM1.
Change it, that's the point.
And then compile?
Yes, and then compile and then download it to your board. But make sure you give it a unique name. And I don't mean call it like HRM2.
And then we can compile it.
Then compile it and download it to your board.
Is there a size limit for that?
See if they all have their names.
Yeah, I believe it's like 56 or so.
Special characters probably bark too. Probably don't want to use apostrophes, ampersands.
Still see a lot of them.
Yeah, we are doing parsing in C, so it's not that advanced.
Now, once you save your name, you can move the.
Yeah, then move it on.
Yeah, you can save it.
Okay, so I can see mine.
Yep. And so now what we're going to do is open up NRF Toolbox. Everyone should have it installed. Click on heart rate monitor, and then connect to device. You should be able to find your device that you just named.
Heart rate. Your phone?
Yeah.
Where did you say it was? Where? Heart rate.
It's effective.
We don't need to reset the board. Just simply understand.
For safety, I would.
If you see the J-Link, open drive, open there it is. It doesn't work on everyone.
So, who can see their heart rate monitor? Really? Everyone's dead? Yeah. You can see it. You can see it. You can see it.
What's wrong with my iOS? Is this an iOS?
Yes, it was.
Master control.
No, for iOS, not this one.
So is it blinking the LED to correspond with our heart rate?
No. Find your name.
There's some kind of subtle competitive. When I line up, it's off right away. I was like, showed it, this is now. And then I did it again, and it worked. So it's same changes that we must have. The first try, it connects, and then go. Second try,
Once the program changing, it just random.
That's next.
You guys thought of that?
So, who cannot see who cannot see it? You cannot see it, you cannot see it, you cannot see it. Can you guys see it?
When you get to 175, resets them.
What you should be seeing is a straight line tick up. Or if you don't have the straight line, you're using master control, you should be able to click on the heart rate characteristic and watch it tick up. You're using Toolbox, it gives you a graph. Master control doesn't give you a graph, it just shows you a number ticking up. So, what we did, if you look at your code inside your compiler, is this little line of code right here. It is HRM counter +1. Once it hits 75, it resets to 0. And each time it increases. So you're just ticking up from 0 to 175 and reset. If you wanted to do it by, say, 5 or 10, change this +1 to 5 or 10. If you want to play around and see some more, do something else. Blink your LED every 5th time. Do whatever you want.
So what's the timing? I know the counter, but where's the timing of how many times it updates?
So what's happening is you hit this BLE. So if you look in the code in the compiler, there's a ticker that happens every second, I think it was. It's outside the scope of this. I couldn't fit that much in.
There's an advertising interval.
No, the advertising interval is how often it sends out an advertising packet. Once you're connected, that becomes a record. Yes, sir. So, when you find back in there, go back, reset on your board, because odds are you already initiated the session. Now try and find it.
Your heart rate No, before coming here, I took my BLE. Okay, these guys are
but it was sharp.
You found out somebody else.
Right. So is it connect? But it's 3. It's
Okay, so I am just what if I was
There are certain ones which
Still nothing?
Oh boy.
When I say I'm saying sometimes it's not.
Oh yeah, these guys, I think they're just nuts to set advertising. No, it's actually looks like they set positions. That's how I'm understanding. I am personally he's got a very good company. Oh yeah. I mean that's just looking really interesting. I have played. It's so pretty.
I was freaked out a little bit. I was going to wear a future already.
No, who's hacking my
Yeah, I installed from the side.
No, all those BLE set properties, what are they exactly? Are these the flags or are these part of the duration 1000 milliseconds, right? That's how.
This is device information service.
This is advertising, right? So this is the actual how often to send advertising ratio every 1 second. So that's why. I know, but what is that part of the packet? Like
advertising is the first one.
So it would be tied, it would be advertising data. And then balance would be tied. So remember that there was something that are tied to the data.
The link so the link is automatically taken. You can set the advertising type, which is what you do.
Right, because it knows that down the it can generate the packet without you having to express it.
Exactly. So that's what
because this is using an API instead of you dealing with bits and bytes.
That's what I meant, like most companies always have because you'll always use that code to broadcast things. Here's your time and everything else. Automatically generates your data.
Change that. Let's try it.
Go for it.
So when you
control it, I promise it's coming, and that's the reason I kind of glossed over it. The only time I'm going to use bits is when we talk about because it's common to refer to those as so you always see but everything else the other stuff always
I can see this running a little bit.
It's really hard to understand.
I know some of the previous slide you had. Inside of your service. I mentioned the characteristic.
Oh, right, we have the services. It's because that's a router on the base layer.
So now I'm stuck. If I want to connect somebody else in the device.
Disconnect.
No, but I disconnected, but now.
Broadcast out data. It's actually a form of help beacon. And so broadcast out things. That's how you, if I walk away from it, trigger something. Because the phone, you can't see it anymore. Sure. It also has an extra service characteristic for writing stuff too to save turn. Title does use
That didn't work. Changing every second.
Well, I didn't do anything else, but
so, everybody, can I have your attention up here, please? We're going to now move on to the next section, where all your questions about UUID are answered. As it stands, you should be a little bit confused. It's because I kind of had to gloss over it, so I have to make you aware of it, and now I'm going to show you how UUIDs are built. I'm going to do this with the SIG webpage, because it has a database that contains every well-known UUID. So those 2-byte UUIDs, this is where you're going to find them. I should mention, every service and characteristic is always 2 bytes if it's defined by SIG. And they do that to reduce the overhead. If you want to create a custom service or a custom characteristic, you have to have a 16-byte one. Savvy? Use a standard, you get 2 bytes. Custom, you get 16 bytes, or you pay a lot of money and they create a new 2-byte one for you. Okay. We're going to go build a heart rate monitor. I'm going to walk you through how to find all the services and characteristics in your UUIDs. So we're going to go to developer.bluetooth.org. And it takes you to this landing page. I'm going to highlight GATT specifications How am I doing on time? Cool, I'm good. Add specifications, go down to the bottom. If you notice, they have these in reverse order because the guy who made their web page is ridiculous, as you'll see in about 30 seconds when you see the rest of the page and realize it truly, truly is ridiculous how they organized everything. So you've got profiles, and then services, characteristics, and descriptors. Yeah, remember that it's flipped over. Profiles are at the top, and services, characteristics, descriptors. So I'm going to look at profiles. I also need to bring back.
So these are the official 2-byte ones, basically.
Yes. Keep in mind, profiles are just for us. The machine doesn't care about profiles. Profiles are just a handy marketing way of saying what services you're using.
Because they're well classification.
Right. So you'll notice there are no UUIDs on this page for the profiles. None whatsoever. I'm going to look at heart rate because we've used that in 2 examples now, and I'm just going to stick with that. So I'm going to click on heart rate. And it gives me this wonderfully cryptic page. Like I said, it's well designed, isn't it? If you look on the left-hand side here, you've got this thing that says service, and you've got 2 things under it. It may not look like it, but each of these are actually links to subpages. And this is going to be a theme that continues. Subpages on subpages on subpages on subpages. The heart rate profile has 2 services. One right here is labeled as heart rate service, and one is labeled as device information service. If I click on each one, I'll get the page that describes that service. So I'm going to click on heart rate and device information. If you notice, I just opened up their subtabs right here. So this is the heart rate service. We're going to look at that one first. This assigned number. Guess what that is? That is. Notice how many bytes it is?
2 bytes.
Precisely 2 bytes.
And that's all you know from when the hardware left. That's all the exchange, nothing else.
Right. So when I query a device and I say, what services do you have? It'd say, oh, I've got service 180D, 1809, and 1801. And then I'd go, oh, 180D, look it up. That's a heart rate service, okay.
Question, so earlier you said the UUID could be either 16 bits or 128 bits.
Yes.
In the case of it being 128, do they fill with zeros all the upper, or what happens?
So technically, every UUID is 128 bits. These 16-bit ones, in this case, this 2-byte 16-bit, it actually has another 14 bytes, but when you only pass in 2 bytes, it automatically fills with the SIG standard. So every SIG 2-byte one actually expands out to 16 bytes.
Okay.
There's just always the same 14 bytes after each of the first 2.
It's padded, basically.
Right, it's padded with a well-defined number by the SIG.
Not zeros.
Not zeros, no. Zeros are actually...
They recognize that number to know that you have a 16-bit one?
No, usually if you pass a 16-bit one, it's assumed that the remainder of it is the SIG one.
So I'm saying that when you're parsing the messages coming in, or parsing any of this kind of data,
yes.
You look for that other ID and go, okay, that's a special ID that's really only 8-bit in the front.
Yes.
I guess you just always include it.
Pretty much, yeah.
I'm confused. You talked about the overhead, right? Between doing 2 bytes and doing 16 bytes.
Mm-hmm.
So if the 2 bytes are always padded,
mm-hmm. If it is well known and we agree that, hey, there will always be this padding here if these are the first 2 bytes, you can get away with really neat hashing tricks and compression tricks that the stack just takes care of for you. So as long as we have an agreement that something is going to happen whenever these things happen, you can build really cool engineering tricks based on it. Also, the overhead comes primarily when you're using something like advertising packets, where you say in the manufacturer data field, you have to put your company UUID. If you have a SIG one, you just put 2 bytes. If you have a not SIG one, you have to fill that all out. So it really doesn't come for the descriptors. It comes in like the data field inside the characteristics. That's where you save space.
Right.
But anyways, heart rate service, yeah? So I'm going to erase this and keep notes as we go, or else everyone's going to get really, really lost. Marker. So we have a heart rate profile. Then we have service 1, which is a heart rate service. Yeah. And we have service 2, which is a device info service. Right here, it says that the heart rate service is hex 180D. So I'm going to put that here. And then I'm going to look at what this service has. As I scroll down, I find the characteristics. And I find that there's 3 of them. The first one right here is heart rate measurement. The second one is body sensor location. And the third one is a thing called a control point. One other thing to notice is whether they're required or not. The spec is very verbose. You don't always have to do everything. In fact, I recommend doing the bare minimum, because if you do everything, you're going to go crazy. It's just too much. So over here on the heart rate measurement, I'm in the heart rate measurement service. It makes sense to have that characteristic, yeah? So it's mandatory. The body sensor location, it's optional. And this control point is conditional. Would anyone like to take a guess as to what that means? Mandatory, optional, and
If
conditional?
sensor location is entered, then that might be required.
Say again, conditional means?
If the body sensor location or some other is entered, then this one.
Right. In this case, it's conditional based on a flag set somewhere else in a previous thing. The sensor location is optional, meaning I can include it or not. And the heart rate measurement is mandatory. Notice again, each one of these has got a link to a subpage. Links upon links upon links. So I'm going to open up these 3 characteristics and go link, and then link, and then scroll down to get the third one, and link.
Those are the characteristic types.
Yes. So now if I go into the first one, which is heart rate measurement.
That's what it details.
This is C1, C2, C3, and it was heart rate measurement characteristic. What was the second one? Anyone remember?
Device location, body location.
Sensor location. What was the third one?
Control point. Control something.
Thank you, control. Heart rate measurement characteristic has UUID 2A37. I'm going to put a 2A37 here. And I'm going to look at what goes in the characteristic value. Remember, every characteristic has one value. It can be multiple bytes, but there's only one value per characteristic. In this case, it has 8 bits of flags. Everyone see that? 8 bits? And then think of flags. And over here on the right side, it defines what those 8 bits do. As I come down, I find more stuff. This one is 8 bits, this one's 16, this one's 16, and this last one is 16 as well. So in theory, I'm going to have 8, 16, 16, whatever.
And all this is called the value?
All this is the value. So it'd be, sorry, I have to turn around. So it'd be 8, 16, 16, what is that? 16, 8 again.
Yeah.
And so those in that order is what you'd have. The first byte being the flags for everything that comes after it. That said, if you look right here under field requirement, which is the second column, the first one, the flags are mandatory. The second one, the third one, the fourth one all have C's next to them. C stands for conditional, which means somewhere in those flags, there's a bit field that says whether or not these things are going to exist. So let's go take a look at the first thing, which is the heart rate measurement value, 8 bits right here. Its requirement is C1. And so what I'm going to do is scroll back up. And sure enough, on the right-hand side here is C1. I can barely see that. Can everyone see that? So if I look at it, it says bit 0, size of 1 bit, is the heart rate value format bit. If it is a 0, we use C1. If it is a 1, we use C2. If I scroll down to look at C1 and C2, it's a 8-bit heart rate measurement value. for C1, and a 16-bit heart rate measurement value for C2.
Right. Supporting both.
Right.
And the flag dictate which standard you're using.
Exactly. So for the heart rate characteristic, I would have something that looks like, let's say a 0, because I don't want to have to do anything more than 8 bytes of value. I then scroll down to see what comes next. Energy expanded. This thing relies on C3. RR interval relies on C4. Let's scroll up and see if I can get away with not doing them. Sure enough, right here, C3 and C4. If I say 0 and 0, I don't have to deal with any of them. I can just totally ignore them. So that leaves this flag, which is sensor contact feature is not supported in the current connection. Cool, something else I don't have to do. I'm not going to do it. Look at the rest of my flags. The rest of my flags are reserved. So I'm just going to have all zeros for my first 8 bytes, or my 8 bits. So it's going to be 0, 0. And then because I did that first 0, that says it's an 8-bit heart rate measurement. So I then have 8 bits of heart rate measurement. What do you want your heart rate to be? Anybody?
Normal.
80. 80. Okay, 80. Hex 80.
Hex 80. 120.
Exactly.
Excited.
So this is your characteristic value now. So if I were to send this across the air at this point, I would have 180D, which would have a characteristic of 2A37, which would have a value of 0080. S1, C1, that's right?
Yeah.
V.
Yeah.
This would be V sub C1.
So where does the descriptor fit in, just out of curiosity in this case?
Notice it's not here.
It does have a descriptor.
It does.
It has a bucket for it.
Where is it?
Go back a page.
Go back a page. Going back a page.
Go up.
Go up.
On the right. Descriptors.
So it does. Well caught. So you do have a mandatory descriptor. Good catch. Thank you, sir. So descriptors are in fact used. I was totally mistaken. I'm going to ignore it though for the sake of clarity of the experiment. So now I'm going to go to body sensor location since we exhausted all of heart rate measurement. Body sensor location has got a value of 2A37. So it's going to be 2A37.
2A38.
Wow, I'm tired. So this will be C2. This will be 2A38. Notice how it goes 37, 38. It might have been because they generated it all at the same time, or just like next number, next number, next number, next number. So these are the value fields for the characteristic. It has precisely one thing. It's 8 bits. And it has these values.
It's a simple one.
So are these characteristic IDs unique within the service or universally unique?
In this case, we are looking at the Bluetooth SIG specification. The UUID for the characteristic are universally unique. That said, the definition that we are using for heart rate service says this service has this characteristic and this characteristic. You could easily define your own service with not 180D, say AA3F. And then you can put the same things in them. But that's, again, a custom definition that you're doing. And that would have, instead of a 2-byte one here, it'd be 16 bytes because it'd be custom.
Right.
And if you're using the standard ones, each of these would be 2 bytes. But if you say you wanted to add another one that was a custom one, then that one would be 16 bytes until you paid them up. So let's say...
Pay for less. That's kind of cool.
Hmm?
I'm just saying you pay for less.
It is weird, isn't it? Although computers are going that way too. Anyway, so I'm going to say it's on my finger, which is a key of 3. So I'm going to give this thing value equals 0x03. So B sub C2 is 0.3. Any questions so far? Cool. I'm now going to go to the next characteristic, which is 2A39. So this is 2A39. I'm going to look at this thing. Heart rate control point, field requirement mandatory, 8 bits. Oh, resets the value of energy expense there, RFU, RFU. You want to give it a value? You want to leave it alone? What do you want to do?
It wasn't mandatory in the other.
We said it's not supported.
Oh, that's right, we did, didn't we?
This is wrong where it says mandatory because it's an option.
You want to write a complaint? Please do. In that case, we're going to ignore this one entirely because it was indeed optional.
Condition.
Sorry, conditional. Wow. Running on very little sleep.
So if you go back to the previous page, does it tell you on what condition?
Yes, it says conditional right here.
Right, and on what determines the condition?
Flags.
The paragraph right above it.
Characteristic
If
is
the
mandatory
energy
if the energy expended feature is
Here.
supported.
This characteristic is conditional. The characteristic is mandated if the energy expended feature is supported, otherwise excluded. Because energy expended, what was it? That was a flag we set initially, right?
Yeah, we said everything.
Yeah. So we set that back up there so we can now ignore this thing entirely. It's not going to exist. So that is all of that service. That's all it is. Now if we go back to the device information service, this is going to be 180A. I promise I'll speed up here very soon. So S2, 180A. We can scroll down and look inside of it. And as I said, it's got like 8 characteristics. And if you notice, every single one of them is optional. So you can add it or not add it as you see fit. I'm going to choose to ignore every single thing inside of here for the sake of speed. So I'm going to have absolutely nothing inside of here. And that's all right. That's my entire profile. Any questions on how I found this data? Cool.
When you say that's your entire profile, can you explain it a little bit?
So this was the heart rate profile.
Right.
We looked up the services,
Right.
we looked up the characteristics, and we looked up the values for inside of them.
I mean, the population of a sample profile, is that what you're saying, data-wise?
Yes. That would compose my entire profile's data. The reason I've chosen to explain this slightly technical thing to you is the BLE apps that exist are terrible at translating from machine to English. And so you're going to run into something that looks like this eventually, where it says, I've got service 180D characteristic, 2837 characteristic, 2838, and here's the values on them. And you need to know how to go look it up on the website.
So there's a reverse lookup. So given the number, we can find the...
Right. Because very few people have built that into their applications.
Like a DNS for BLE?
Very few people have done that. It's a very fragmented field, unfortunately.
So who sets all these rules, like all the data?
All the UUIDs,
BLE?
those are set by the
the
city.
actual format of the...
Oh, that's defined by the GATT format. This is a GATT format, this is...
No, the GATT
this is what
format,
GATT
but...
is.
Oh, really?
GATT is the composition of service to characteristic to values. That's what GATT defines, is this hierarchy that we just saw here.
Application level type, almost, or like, or whatever you call it.
The application will use this.
Right.
GATT defines the levels, applications put stuff into the levels. Okay, back to the presentation. That was the SIG website. How are we doing on time? We have 15 minutes. Something tells me I can either whiz through this and send you all home with homework, or we can go over it next month. What do y'all want to do?
Just whiz through it.
Homework.
Let's go through it. Let's do it if we don't, we're defeated.
So what? Ah, good point. And all of y'all made sure to grab the slides, clearly, when I had them in broadcasting, right? Okay, so there's this really cool thing that I like to use called Evo Things. Evo Things is built on Cordova or PhoneGap. If anyone in here is a mobile developer, raise your hand. You know what's up, you know what's up. Essentially, it is a hardware abstraction library. It allows you to run identical code in JavaScript on iOS, Android, or Windows Phone. Certain parts are kind of buggy. Until 3 months ago, nothing existed for BLE. And then these guys came along with a rock steady product, and I've been hacking with them for about 3 weeks now, and I absolutely love them. So I'm going to preach the gospel to y'all and send you home to hack on it. So the first thing you're going to do is go to the Evo Things website, download their thing, they'll hand you a zip file. The zip file's got an executable, you run the executable, no install. It just runs as an exe. It also has a smartphone app. That smartphone app is on the iOS store and the Android store. And it looks like this. This is the client. This is the workbench. Client, workbench, client, workbench, client, workbench. What you do is you open up the client. It looks like this thing up here. This is, you click the scan for workbench button. If your device and your computer are on the same Wi-Fi network, they'll find each other. So is there anything else important? This is what the workbench looks like. You've got a whole bunch of example programs you can run. You can click run and run them. All these are written in Java, and they all can exist, they're composed of a web page, which is index.html and app.js. Those two things are what the entire app is. Most of these apps are 100 lines or less. Most of that is white space and brackets. So I'm going to show y'all the BLE scanner right here. And yeah. So now I'm going to open that up and just run you through it. So this is what I downloaded. This is the contents of the zip file. This is the workbench. I'm going to open the workbench. It looks like this because I've been playing with things. Should probably actually open the BLE Explorer. Yeah, none of these are actually good examples. So this one back real quick. It's actually a great example. So if I go into the examples folder, here are all the examples that this thing has. I'm going to go into BLE Discovery. This is the index.html file. This is the application file. So I go back up, drag index.html, and have BLE Discovery. I'm going to take my tablet, which should be gloriously connected, if everything goes in my favor. Run the Evo Things app, click on the Scan for Workbench button, and I'm finding someone called GlackMac Local, which is not mine. So I'm going to instead just look down here in the bottom left for my IP address and type it in. Which is 192.168.32.113. Hit the connect button. It says connecting, and hopefully it'll actually work.
You don't need to stick in the port number?
No, it automatically fills it in.
He gave you 2 addresses to try. You might be looking at the wrong networks.
That could be, couldn't it? What was the other one? 56.1?
The main branch with the device ID change.
56.1.
Connecting. Something tells me this isn't going to work, so let me double check which network I'm on. I'm on Capital Factory. This one's on Capital Factory as well, so it should be connecting. I don't know why it's not. I have no explanation. Who has GlackMac? You've got GlackMac.
Yeah.
You don't have Evo Things, do you?
I do.
This thing?
Yeah.
Open it up for me.
I do.
Awesome. I'm going to connect to you. I'm connected. Go ahead and run BLE Discovery for me, please. It says loading, and now it just ran the application from his computer onto my tablet. It does this because it opens up a TCP port and goes, here's your JavaScript, and then it runs it, and it goes, oh, cool, run a check, I'm running on Android. Okay, pipe towards the Android library, but the top level API is exactly the same, whether I'm on Android or iOS. I can then say PS lamp, that's yours back there? So he's got PS lamp. I'm going to click on PS lamp. It is going to scan every service and characteristic on his device. And it's going to take about 30 seconds. Oh, hey, there it is. So I'm going to walk around and show y'all. It now has all of his services and characteristics listed. And I can expand them out and see what he's got. And so this is what you're going to see when you try and do BLE debugging. Notice how there's a bunch of really long UUIDs? This is why I took the time to explain what UUIDs are, because this is how your debugging is going to work. That's how it's going to end up looking. If you have the time and the patience, I highly recommend taking a look at Evo things. It's really nice for
So
debugging.
each line is a service, not a profile?
See how it says S right next to it?
Yeah.
S and C, that's why I use the same terminology.
Okay. So there's no grouping to profile?
Correct. The device does not care about profile. Profile is entirely an English language construct, so we can say, oh, I'm using the heart rate profile. Instantly you know I mean what services. Or instantly you know which services I mean. There we go. That's all I got.
Nice. Thank you.
Yeah. So if you'll check out the Meetup page, I put the slides up there. I also put a Google Doc that I'm like 80% done with. I still got to add a few things tonight up there that runs over the exact same content. So if I wasn't clear on anything, you can reread through it and check everything out. Actually, I've got a slide for what I'm doing right now, and I'm really proud of it, so I'm going to throw it up here. Okay, so next week. Now you can BLE. Next month. Next month is custom services, where we're going to talk about how to build your own, how to pack your own advertising data, how to make it work for you and your custom services. And we may even, if I get time, say reverse engineer a Fitbit or something like that, so we can see what their custom services look like.
So it's just interoperability you want to use.
Right. I want to stress that. If you want to work with stuff that exists, use the standard services. If you want to break it and go your own, roll your own. Please check out the Meetup page. It has a feedback form along with links to the slides and Google document and Google Doc. Please give me form feedback because it's how I validate my existence. Thank you and good night. And take the pizza and beer home.
Thank you.
Yeah. Oh yeah, and the boards. Return the boards. I need those for next month.
How much are you boards? How much is it?
Ranges between $20 and $60, depending on what you buy.
Can you show me how to do this?